It's just before 6 p.m. Eastern Time on Thursday, July 25th, and we're looking at a live view of Cape Canaveral Space Launch Complex 40, where a flight-proven Falcon 9 is about to launch a flight-proven Dragon spacecraft.
Dragon, with some help from Falcon 9, will be delivering more than 5,000 pounds of cargo to the space station on this mission, including critical materials to support dozens of science and research investigations that will occur on board the orbiting laboratory. In terms of historical firsts, today's mission represents Dragon's first hat trick. This will be the first time we've flown the same Dragon spacecraft for a third mission, as you can see there by the two flight-proven decals on the left side of the vehicle. This particular Dragon visited the ISS for cargo resupply missions back in April of 2015 and December 2017. You'll also notice another decal on the exterior of Dragon, which SpaceX added to commemorate and celebrate the 50th anniversary of NASA's Apollo 11, the world's first mission to land humans on the lunar surface.
Investigations sponsored by the International Space Station U.S. National Laboratory are primed for launch on SpaceX's 18th Commercial Resupply Services mission to the orbiting laboratory. When we say that this launch is packed with research, we mean it. This launch has more payloads than we have ever sent on a single mission. Private sector companies, academic researchers, STEM projects, life and physical sciences, all on this mission. So let's get an idea about some of the payloads that are launching on SpaceX CRS-18. The Goodyear Tire and Rubber Company is sending what they hope is the first of many investigations to the ISS National Lab. This initial experiment will evaluate the formation of silica particles in microgravity. Silica is a common material used in consumer tires. However, silica and rubber are materials that don't easily bond. Can the microgravity environment of the space station allow Goodyear to find silica morphologies not possible on Earth? If so, this could lead to improvements in fuel efficiency and other performance factors in consumer tires. The space station is an ever-evolving research platform, and NASA and the ISS National Lab are constantly sponsoring new facilities on the orbiting laboratory to increase the capacity for innovative research. This launch, America's first automated bioprinter for use in space, will make its way to station. Developed by TechShot, this bioprinter will initially seek to print cardiac-like tissue. The printed tissues will remain on station until they are strong enough for the return trip to be analyzed on Earth. While the ability to manufacture human organs is likely many years away, this bioprinter could lead to unique methods of industrial biomedicine and microgravity to develop materials for patient care on Earth. Part of the role of the ISS National Lab is to inspire and educate the next generation. And what better way to do that than by forming fun and exciting collaborations with unique partners? Not many young students understand the term non-Newtonian fluidics in a microgravity environment. However, just about every young student is familiar with Nickelodeon and its iconic slime. So on this mission, Nickelodeon Slime in Space will make its way to station for a variety of demonstrations to educate students on the basic concepts of fluid flow and microgravity compared with normal gravity conditions on Earth.
Falcon 9's in startup.
Dragon isn't started. Go for launch.
T-minus 30 seconds. T-minus 15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition. Liftoff.
State on propulsion phenomenal.
Vehicle is pitching downrange.
And there is successful liftoff of Falcon 9 carrying our 18th
Power and telemetry
resupply
nominal.
mission on a Dragon spacecraft to the International Space Station. Now we're currently in what we call the throttle bucket, and that's because in about 30 seconds we have an event called maximum dynamic pressure, or max Q. That's the point where the vehicle experiences the highest aerodynamic stresses. So what we do is we bring down the engines a little bit, pass through that point, and then throttle back up once the atmosphere continues to drop off above that point.
Vehicle is experiencing maximum aerodynamic pressure.
So now we're through that point of maximum dynamic pressure. Now coming up are a series of rapid events, main engine cutoff, then stage separation, followed by second engine start of the second stage's Merlin vacuum engine, and then the first stage is going to conduct a boost back burn, followed by a Dragon nose cone deploy. Now, main engine cutoff, or MECO, is where all 9 Merlin 1D engines on the first stage will shut down. Followed shortly after that is stage separation, and then a few seconds later, the Merlin vacuum engine on the second stage will ignite to boost Dragon into low Earth orbit. In fact, during ascent, you heard the call out for engine chill-in of that Merlin vacuum engine. So again, coming up in about 10 seconds, MECO, stage separation, second engine start, and then stage 1 boost back burn.
MECO.
Stage separation confirmed.
And back ignition. Stage 1 boost back startup.
And you can hear the cheers behind me. You're looking at a successful start of the Merlin vacuum engine on your right screen and the boost back maneuver on your left-hand screen of the first stage. Shortly here, we should have nose cone deploy off of Dragon, and we may be able to see that on the right-hand screen.
You can see Cape Canaveral coming into view. In terms of fuel conservation, we only fire 1 Merlin engine on this final burn, engine number 9, the center engine.
Stage 1 entry transonic. Stage 1 landing burn started.
Our landing burn has begun.
Stage 2 has entered terminal guidance.
You see the landing legs are deploying.
Falcon 9 has landed. Landing operators moving procedure 11.100.
And the Falcon has landed. Congratulations to everyone here at SpaceX for another successful landing. For those of you keeping score, this is our 44th successful first stage recovery. This is our secondary mission at SpaceX. It's our commitment to vehicle reusability. Back to our primary mission.
Okay, so shortly here, and now that camera view at the top of the second stage, that looks into Dragon's unpressurized cargo portion. There, you can see it.
Dragon separation confirmed.
Acquisition of signal, Newfoundland.
You can hear the cheers
This is
behind
Dragon
me.
CC on countdown 1. Dragon senses separation.
Off Dragon goes
Thanks
for
for the
its
ride.
mission to the International Space Station. The Dragon team doing a little handoff with Falcon there.
As mentioned previously, Dragon is carrying tons of cargo to the International Space Station on this mission today. A small portion of the cargo represents supplies for the astronauts, things like food and clothing and personal items, but most of the cargo represents science going up to the space station. The ISS serves as the world's leading laboratory where cutting-edge research and technology development help enable human and robotic exploration of destinations beyond low Earth orbit, including the Moon and even Mars. In about a minute, we'll have our final milestone that we'll be covering in today's webcast. It's our solar panel deploy. There are 2 solar arrays located on either side of Dragon's trunk. And at about T plus 12 minutes, they'll begin to unfold almost accordion style over about a minute or two, and they help power Dragon on its several-day trip to the International Space Station.
This is Dragon CC on countdown 1. Dragon's propulsion system has successfully primed, and all thrusters report ready for firing.
And over the next couple days on its trip, the next milestone that occurs is opening of the GNC door, the Guidance, Navigation, and Control door. There are various sensitive components that can't be exposed to the atmosphere during liftoff that help navigate and help the Dragon understand where it is on its trip to the space station. That'll occur a couple hours after liftoff. But we are about 15 seconds away from solar array deploy. And currently here on the left-hand camera, that's where we're watching for solar array deploy. The solar panels are packed right up against that camera view, and once they deploy, you'll begin to see them expand and see the rest of our gorgeous view here from Dragon as well.
This is Dragon CC on countdown 1. Dragon is deploying its solar arrays.
And we've heard the call out. You see the expansion there. We've successfully begun to deploy our solar panel arrays, which will occur over the next couple minutes. And at this point, we will end our webcast coverage for today's mission. To recap what happened, we had a successful launch of the Falcon 9 at 6:01 p.m. Eastern Time. We had a successful stage separation, a successful 44th landing of our Falcon 9 at Landing Zone 1 at Cape Canaveral, and this is the first time a Dragon capsule is heading for its third trip to the space station. Dragon's arrival, capture, and installation to the ISS will be streamed live on NASA TV starting Saturday, July 27th at 8:30 a.m. Eastern Time. Dragon will spend about 4 weeks, like we mentioned, attached to the space station before returning to Earth with cargo and research to send back.
So over the next 2 days, we're going to be posting mission updates on both NASA and SpaceX's social media accounts. So please follow us there if you want to continue to get updates about today's mission. We want to give a big thanks to the Range and the Federal Aviation Administration for their support of today's mission, and a huge thanks to our customer NASA. A big congratulations to them for the 50th anniversary of the moon landing, and thanks for their continued support of SpaceX. Finally, we want to thank all of you, our viewers, for joining us today, and until the next time, we hope you have a great rest of the day.